Beryllium is one of the many elements that people mine, and that's how we obtained it for NASA's James Webb Space Telescope. It exists in many rocks, just in tiny quantities. We collected rocks with the highest amounts of beryllium, crushed them up, put them through many chemical processes, and these rocks only have 0.25% beryllium. To explain beryllium's rare beginnings, we need to talk about the cosmic origins of most elements. When a massive star is forming, it's mostly two elements, hydrogen and some helium. Over time and pressure, temperature builds up in the core, so much that some of the hydrogen atoms fuse, creating helium and officially bringing the star to life. That fusion creates a tremendous amount of energy and is literally what fuels the star and makes the light we see. That star will eventually run out of hydrogen and the helium atoms start to fuse, creating even larger atoms. That keeps happening, and we get larger and larger elements. These new elements are denser than the former hydrogen and helium, and they cause the star to contract and get even hotter. But that all stops with iron. There isn't enough energy to fuse something more substantial, so once there's too much iron in a star, which means that there's no fuel, it dies, but not without a dramatic exit. The core collapses under the pressure, and all of the atoms knock around into one another, which causes a sort of shockwave, and it explodes into a supernova. This is the energy needed to create heavier elements. This is when more than half of the elements in the periodic table are made. But beryllium is not in that mix. Look at where it is on the table. It has an atomic mass of 4, much smaller than the heavy new elements. So why isn't beryllium made when the other small elements were? It's just too unstable. If, during the chaos of a supernova, a cosmic ray hits one of these newly formed larger elements, a special reaction happens. This is called cosmic ray spallation. This ray hits a molecule and it bursts into smaller particles. The pieces can continue splitting into smaller parts, some of which turn into beryllium. It takes a supernova and a cosmic ray to reduce a large element into what could be a variety of combinations and sizes to create beryllium. No wonder it's so rare.